Good morning, everyone. My name is Yanjun from Zhejiang University of Technology, the Institute of Energy and Power Engineering. Currently, the main research direction of our team is the resource utilization of organic solid waste and its thermal disposal equipment. Today, the title of my presentation is Insight into the microstructure evolution and high-value utilization of activity, the carbon derived from biomass and sewage sludge. I will present my research content from the following four parts, and the research background and the main research content, also the result and the discussion. With the rapid growth of sludge production, China has issued opinions on sewage sludge disposal and utilization during the past years. The safe disposal and resource utilization of the sewage sludge has become a very important task in China's course of environmental pollution, prevention and control. The efficient resource recycling of the bulk municipal sludge and the carbon will become a hot direction. Our team mainly focuses on the potential of convert sewage sludge to prepare high-value carbon materials in terms of the feedstock composition and its potential role. The heteroatoms and the inorganic substances contained in sludge can play a good role in the preparation of carbon material. And the sludge-based carbon material after thermal chemical conversion has a multi-layered hierarchical structure and are rich in nitrogen and oxygen containing functional groups. So far, direct pyrolysis carbonization, hydrothermal carbonization as the main method of carbon material preparation has their own advantages and disadvantages. Hydrothermal carbonization as a kind of the green and low carbon preparation process has been emphasized in the field of carbon material. So based on the principle of matching raw material with the process, our team consider the high water content of sludge, adopts hydrothermal carbonization to change the sludge, and utilize it as chilled material and a solvent by operating with the traditional biomass in a high value way. So based on the above assumptions, the main research of our team is the sludge carbon material preparation. By designing the sludge hydrothermal carbonization activation preparation process and comparing it with the direct pyrolysis carbonization activation process. So we evaluated the different carbon-based material. In order to further improve the properties of activated carbon in the first part of our study, we prepared electrode materials by mixing sludge as heteroatom doping source and in organic template and biomass as the supplemental carbon source, and explored the effect of the instruction of sludge on the improvement of the physical, chemical, and the electrochemical properties of the carbon. So in the third part of our study, we prepared activity carbon by mixing sludge with coffee grounds of different ash content and evaluated its CO2 adsorption properties. The sludge-based Beltra obtained after hydrothermal acidification and the paralytic activation were both a three-dimensional porous layered structure. Among them, the surface of sludge hydrothermal carbon was flat and smooth, and there were no pore and laminar features yet. But after activation, a large number of the pore structure appeared, indicating that chemical activation was the source of pore creation. Well, paralytic carbonation was obvious, and it had already generated a complete carbon scalene and some irregular pores, and the laminar effect was even more obvious after activation. Pore characterization of the sludge-based pore carbon revealed that the pore structure of sludge hydrothermal carbon is very poor, and it doesn't yet have potential to become a high-value carbon. Whereas the adsorption curve of both the sludge hydrothermal activated and the paralytically activated carbon are typical IV type adsorption curves. Well, that shows there are macro pores, mask pores, and micro pores within the material. Moreover, it's found that the specific surface area of the carbon material shows a rising trend with the increase of the temperature. The presence of the nitrogen containing, I think the screen has a problem. Okay, the presence of the nitrogen containing functional groups has been shown to be beneficial in improving the electrochemical properties of the carbon material. After hydrothermal treatment, quaternary nitrogen and the nitrogen formed from pretend nitrogen decompositions appeared inside the sludge hydrothermal carbon. After the acidification treatment, the pyridine nitrogen began to appear. The N6 content of pyrolysis carbon has the highest percent of different forms of nitrogen, which can lead to higher electrochemical property. In the electrochemical test, we used activated carbon to participate in the construction of the 3 electrode system and evaluated its electrochemical property by CV, GCD, and EAS. The cyclic white telemetry tests were performed on both materials. And it was found that the redox peaks induced by the N-doping of the sludge itself could be observed in the CV curves. Okay, let's see the next slide. So in this slide, we can see the different the curves, the scaling curves of the both material were found to be at a different scaling rate, and the curve were not distorted even at 50 MV per second scanning rate. The sludge pyrolysis activated carbon shows a better specific charge, which may be attributed to the fact that the continuous high temperature treatment during the pyrolysis activation process can enhance the pore distribution structure, which makes the carbon material have the ability to store a large amount of charge. So after the blending of the sludge and the rice husk presented, the sludge acted as a structure directing agent and laminated after fiber structure of the rice husk produced a cross-linking interoperability and a large number of the activation shows a more obvious three-dimensional porous structure than that of the biomass-derived carbon prepared from the rice husk alone. So let's us to see the preparation of the carbon material from the sludge blended with the peanut sands. It shows an obvious reticulated porous structure. So we can, from the right table, we can see that the layered properties. Introduction of the sludge. The introduction of the sludge further development the pore structure of the sludge rice husk derived carbon, especially its specific surface area and the portfolio were increased. The sludge pennant cell derived carbon appeared to have an obvious uniform distribution of micro, meso, and macropores, and the specific surface area portfolio was also improved. Obvious that NS peaks were observed for both sludge rice husk activated carbon and the sludge pennant shell activated carbon, indicating the N in the sludge was dropped into the interior of the carbon material. Well, the low nitrogen content of the rice husk and the peanut shell itself, which is heavily dissolved in the liquid during the hydrothermal process. In addition, the distribution of carbon functional groups of all material is dominated by the double carbon, and the presence of the carbon-oxygen-nitrogen bonds further confirm that the surface carbon material is rich in nitrogen and oxygen heterotherms. The nitrogen form of all samples could be roughly categorized into three groups: nitrogen, pyridine nitrogen, and quaternary nitrogen. And the introduction, the sludge made the pyridine nitrogen content extremely elevated, especially the nitrogen 6 content was high as 49.3%, and the pyridine nitrogen 6 is more favorable compared with the nitrogen, that's nitrogen 5. The obvious redox peaks caused by sludge nitrogen doping was observed for both sludge rice husk activated carbon and sludge pennant cell carbon at 5 MV per second scan rate. And in the this charge test, the sludge rice husk activated carbon can reach 220 F per gram at 1 per gram current density, which is better than that of the rice husk activated carbon due to its higher specific surface area. The superior pore characteristics and higher nitrogen doping, Well, the sludge peanut shell activity, the carbon has a very high specific surface area and the nitrogen content. The decrease in macroporous properties leads to a certain decline in charge storage. Generally speaking, the sludge rice husk activity carbon has the best electrochemical properties among the 4 carbon materials, as well as good multiplicity property and the ability to charge and discharge rapidly at high current densities. In addition, we observed that the equivalent series resistance of the both activity the carbon obtained after the introduction of sludge decrease. It could be attributed to the structure directing effect of the sludge and templating effect of inorganic materials, and compared with the electrochemical property of the other electrode material, all of our prepared the activity, the carbon has a good property. Irregular pore appeared on the surface of the high ash sludge activity, the carbon, and the low ash sludge activity, the carbon, because we selected the 2 kinds of the pseudo sludge. One have a very high ash content, and another kind of the sample has very low ash content. But the overall number of the pore structure was very low. After mixing with coffee grounds, the number of the pore structure increased significantly as the proportion of the coffee grounds increased from 50% to 65% and 80%. The pore structure of the activity carbon prepared with the low ash sludge was obviously richer, and the pore size was smaller. And the overall pore structure of the carbon prepared with 20% low ash sludge plus 80% coffee ground reach a comparable level with that of the activity carbon with coffee grounds. So it's also that the honeycomb shape and a dense distribution of a small pore size pores. The sludge activity carbon presents a more pronounced class IV isotherm properties, while the sludge coffee grounds based the carbon present a combination of the class 1 and class 4. The sludge biomass carbon showed a pore size distribution characterized by the predominance of the macroporous distribution and the coexistence of the mesoporous structure. With the increase of the proportion of the coffee ground in the raw material, the pore size distribution of the activity, the carbon, is obviously transferred to the macroporous and the ultra macroporous region, which are more favorable to the CO2 adsorption's capacity. The low specific surface area of the sludge-based activity, the carbon, when we mix with coffee grounds, the portfolio and other parameters are enhanced. 20% of the 2 types of sludge and 80% of the coffee grounds produce activated carbon with higher portfolio than that of coffee grounds. That means the separate coffee ground carbon. I think that indicates that that the low ash sludge has a certain structure orientation when mixed with coffee ground, and it can enrich the pore structure of the carbon. The figure in the right shows the Raman spectral curves of the activity the carbon in the specific phase. The relative intensity of the D and G band indicate. Oh, sorry. I think the screen is very quick. The D and G band indicate the degree of the defect, and a high ratio indicates a high level of the defect. The figure clearly shows the high ash sludge carbon has no obvious G band, and the carbon scalene structure is unstable. While the low ash sludge carbon has obvious D and G band, we can see from the left figure. After mixing with the coffee ground, sludge coffee grounds-based carbon gradually increased the ID and IG values as a proportion of the coffee grounds in the raw materials increase, implying a more developed pore structure. It is also favorable for its adsorption capacity. So the sewage sludge with lower ash content was more suitable as a structure gate for enhancing the structure and the CO2 adsorption property of the coffee ground activity carbon. Moreover, the CO2 adsorption capacity of SAC-20 and the CAC were both higher than that of the normal carbon. The normal activity carbon has 2.6 mole per gram. The structure directing effect of LS can be used as a direction for the structure of carbon material and the CO2 adsorption property in the future. That's the way we think. So, so far, we can draw some conclusions that the activity the carbon prepared by hydrothermal carbonization activation of the sludge is rich in mesoporous structure, and the nitrogen oxygen functional groups. And the activity the carbon coupled with biomass has structural advantages over the activity the carbon prepared from the biomass alone. So I think that makes it excellent in electrode materials application as well as CO2 absorption. The inorganic template role played by the sludge as well as the structural orientation role is noteworthy. So it is of green significance for the high value application of sludge. Okay, thanks for your attention. That's my presentation.